Hello, class. This recording today is on Chapter 6 of the ER book, Extending Relationships, Structural Constraints. So far, we only talked about relationships. We talked about entities, we talked about attributes, and we talked about entities having relationships. In this chapter, we will describe the nature of relationships a little bit more. So, to describe the nature of relationships, we have what's called structural constraints. And there are two types of structural constraints: cardinality constraints and participation constraints. So, structural constraints basically discuss how entities are related to one another. And there are two types of structural constraints. They're cardinality and participation. We will talk about each one of these constraints. First, we'll start with the cardinality constraints. We have what's called a cardinality ratio between two entities. The cardinality ratio is an approximate measure of the number of entities that will be related to another entity. So there are four kinds of cardinality ratios. There's a one-to-one ratio, a many-to-one ratio, one-to-many ratio, and a many-to-many ratio. And again, I'll discuss every one of these ratios in order. So first, starting with the one-to-one ratio. The one-to-one ratio is written as, for example, if you have an entity called employee and you have an entity called parking space, a one-to-one ratio would mean one employee parks in one parking space, and one parking space has only one employee parking in it. So, if you look at the diagram on slide 6, which shows the employee parking space relationship as a one-to-one relationship, notice we have a 1 between the employee and parks relationship, and there's a 1 between the parking space and the parks relationship. So once again, there is a one-to-one relationship between the parking space and parks, or rather, there's one employee can park in only one parking space, and one parking space can only have one employee parking in it. The next type of cardinality ratio that we have is a many-to-one cardinality ratio, which means that many entities are related to only one of the other type of entities. So, for example, a supervised employee to supervisor relationship may be many-to-one. So employees, or rather many employees, or more than one employee, so basically employees are managed by one supervisor. So many employees are managed by one supervisor, and one supervisor manages many employees. Now, when we refer to the term many is anything greater than one. So many employees are managed by one supervisor, but one supervisor manages many employees. So here's on slide 8 a pictorial representation of the supervisor entity, the managed relationship, and the employee entity. So one supervisor manages many employees, and many employees are managed by one supervisor. The next one is a one-to-many relationship. A one-to-many relationship means one entity is related to many entities. So this could be, an example of this could be an employee to dependent. So one employee is related to many dependents. But every dependent is only related to one employee. Again, pictorially on slide 10, we have the employee to dependent relationship. So one employee is related to many dependents. So one employee can have many dependents, but many dependents may be related to the same or one employee. So basically, if you're thinking of dependents as children, so one employee can have more than one child, but all the children are related to only one employee. And the last one of these cardinality ratios, the many-to-many ratio, many occurrences of one entity are related to many occurrences of another entity. So the employee-to-project relationship. One employee or an employee is related to many projects, and a project is related to many employees. So one employee cannot work on more than one project, and one project may have more than one employee working on it. So turning to slide 12, we show the employee-project relationship. This shows that a project has many employees working for it. An employee works on many projects, can be working on many projects. So that was the cardinality ratio. The four kinds of cardinality ratios, once again, are the one-to-one, the many-to-one, one-to-many, and the many-to-many cardinality ratios. So basically, this tries to explain how many of one entity are related to another entity. If we have more than one entity related to another entity, we term that as many. So many is any number more than one. The next kind of constraint that we have, that we discuss in relationships, is the participation constraint. The participation constraint, there are two kinds of participation constraints. There's the full or mandatory participation, and there's the partial or optional participation. The full or mandatory participation means that every occurrence of an entity must participate in the relationship. Must is used for full participation, and pictorially this is shown by double lines on the ER diagram, which we will show in the next slide. The partial participation means that an entity may or may not participate in the relationship, and the partial participation is depicted by a single line. So looking at slide 15, we have a double line between the dependent and the related to relationship. So this means that this is full participation, which means that the dependent must be related to an employee. An employee has partial participation. That means that an employee may have dependents related to it. So basically, what this is trying to explain or depict is, if we have, say, for example, a database of 50 employees, not every employee has a dependent. Okay, the partial participation means that not every employee participates in this relationship, which means not every employee has a dependent. But if there is a dependent, that has to be related to an employee. That's what the full participation means. So if there is a dependent, that has to be related to an employee, shown by the double lines. Again, the cardinality on this was one employee may have many dependents, and the cardinality gives us some information. The participation gives us some additional information. So the English description: each employee may be related to many dependents, and each dependent must be related to one employee. Okay, so if we were to talk about the methodology, developing the methodology, we already talked about steps 1 and 2 in the previous slide, so I'm going to skip over that. We talked about step 3 in the previous slide, so I'm going to skip over that. And now, looking at step 4 for this set of slides, review the specifications to determine if entities are needed. That was also in the previous slide. Going to the previous set of slides. So going to step 5, connect new entity via relationship, if possible. Include structural constraints in the relationship, the cardinality and the participation constraints. Step 6 says, state the exact nature of the relationship in structured English from all sides. Notice the from all sides. The relationship is not complete unless you say something like, an employee may have many dependents, the may coming from the single line, and that gives one set of information. The dependent must belong to an employee. That gives another set of information, the must meaning full participation. One employee may have many dependents. That gives another set of information. Many dependents may be related to one employee. That gives another set of information. But what you will notice is, so going back to slide 15, when I said that in step 6 of the methodology, when we said state the exact nature of the relationship in structured English from all sides, we need to state the relationship going from employee to dependent and from dependent to employee. So once again, the employee and employee may be related to many dependents, but a dependent must have an employee related to it. An employee may or may not have many dependents. A dependent must have an employee related to it. So the relationships have to go from both sides. The cardinality, one employee may have many dependents. Many dependents must belong to one employee, the cardinality. So both the participation and the cardinality have to be stated from both sides. That's why if you notice on step 6, it says, state the exact nature of the relationship in structured English from all sides. Step 7 says, present the design to the user, and step 8 says, show some sample data. Okay, now that we have talked about the relationships, the cardinality, and the participation constraints, the next step would be to map these relationships to a relational database. So we'll start off with mapping the binary M-to-N relationship, because in a way I treat that relationship, the binary M-to-N relationship, as the easiest one to map, because what we do is we create a new table for each M-to-N relationship, and the new table will contain the primary keys of each of the two entities, and the table key of this table will be the concatenated keys of the two entities. So for example, if we have, on slide 22, an M-to-N relationship of a project to employee, so an employee may work on many projects, and a project may have many employees working on it. The ID, the key of project being project ID, the key of employee being employee ID, and employee has one other attribute called name, and project has one other attribute called project manager. So mapping this would map to, the M-to-N relationship this would map to, you would have the employee table mapping employee ID as the primary key and the other attribute name. And of course you would have the project table mapping the project ID as the primary key and the project manager as the other attribute. And you formed a separate table for the relationship works on. And notice that the works on relationship takes the primary key of the first entity, employee ID, and the primary key of the second entity, project ID, puts them together, underlines them, and that's the primary key of the works on relationship. So that's how you would map an end-to-end relationship. And that's why it is so important to name the relationship, because we have to directly map from these relationships to a relational database. Now, showing some sample data, we've shown some sample data with employee ID and project ID. Okay, now mapping the binary one-to-one relationship. Include the primary key of one entity, entity A, in the table of the other entity, entity B, as the foreign key. The question is, which is entity A and which is entity B? So basically what it says is you take the primary key of one entity and put it in the other entity as the foreign key, but the question is, which is entity A and which is entity B? So we have some other rules here, some additional rules. Now in the slides the rules are not going in order, but in the book you'll find a better order for the rules. If one side has full participation and the other side has partial participation, store the primary key of the partial participation entity as the foreign key in the full participation entity. So we basically take the key, the primary key from the partial participation, and include it in the side with the full participation. Now you might think that this is a little difficult to remember, but actually it's not. It's very intuitive. What you have to keep in mind is we have to create the best set of tables with the least amount of redundancy and the least amount of null values. So if you take the key from the partial side to the full side, the partial side, as we talked about just a few moments ago, means an employee may or may not participate in the relationship. So a partial relationship means the entity may or may not participate. So, for example, an employee may or may not have a dependent. But on the full side, a dependent has to belong to the employee. So there's always going to be information on the full side, is the idea. So that's why we take the key from the partial side and include it in the full side to minimize null values. And actually, if you remember this idea, you can kind of flow through. I know when you look at the mapping rules for the relationships, there seems to be a lot of mapping rules for the relationships, especially if you're going through the book. It's going to look, initially, looks pretty confusing. Okay, but it's really not that confusing if you just understand it correctly and if you understand it based on just basic intuition, really. Okay, because what you're doing is you're trying to minimize, as I said, null values. And if you take the key from the primary key from the side with the partial participation and include it in the key, included in the table with the full participation, you will be minimizing redundancy. So for example, if we have examples shown on slide 27 where we have a computer, computer has a barcode as the primary key, employee has employee ID as the primary key. So we have two entities, computer and employee. And there is a partial participation relationship between the employee and computer, but a full participation relationship between the computer and the employee. So the table would be, going back again to slide 27, there is a partial participation between the employee and computer, but a full participation between computer and employee. So the computer table would have its own primary key barcode, its own attribute, but also the attribute, the primary key of the employee table as the foreign key. Now there was a partial participation going from employee to computer, so we take the key from the partial side, employee, and include it in the full side, computer. So that's why the primary key of employee ID went to the computer table as a foreign key. And the definition of a foreign key, in case you haven't gotten that yet, the definition of a foreign key is it is a key of some other table. It's not my own key, and I'm just carrying it basically. And here is some sample data with the one-to-one full participation that we just talked about. Okay, now mapping binary one-to-one relationship with both sides partial. There are two options. Option 1, mapping rule 7a, we chooses one side to store the primary key of the other. And in this case, we do not really know, since both sides are partial, your guess is as good as mine. And it doesn't matter which side we take the key and put on which other side, you might have to live with null values either way. Now, if you have prior information about the data or you're knowledgeable about the data and you know that it's partial participation going both ways, but one side of the table is probably more full than the other side, then you would, in that case, probably take the key from the side that you think is more leaning towards the partial to the full. But if you did not have that information, you would have to, it would be pretty much random, and so you might have to live with null values, because it doesn't matter which side you took the key from, you would have to live with null values either way. Okay, the next rule, option 2, is create a new table with keys for the two entities as done in the end-to-end example. So those are the two options that you have with binary one-to-one relationships with both sides being partial. Okay, so the next slide shows a binary one-to-one relationship, and in this case both sides are partial between the computer and employee, and the employee and computer. They're both sides are partial. And in this case, using option 1, we just took the employee ID and put it in the computer table, much like we had done when there was a full participation on the computer table side. And here is the data showing what was mapped in the last slide. And using option 2, we would have a table called users, much like the end-to-end relationship, that takes the primary key of the employee table and the primary key of the computer table, puts them together, underlines them, and that is the end-to-end relationship. It is just like the end-to-end relationship, but that is the second way of mapping partial one-to-one relationships. And again, we show some sample data. Now, mapping relate states, if both sides have full participation, what do we do? You use the semantics of the relationship to select which of the tables should contain the key of the other. If this choice is unclear, use mapping rule 7b, create a separate table to house the relationship, just like we did for the partial one-to-one relationship, or rather the end-to-end relationship. So here's an example of a full one-to-one relationship. So a computer has to be used by an employee, and an employee has to use a computer. And using the one-to-one full relationship here, the first one, we've taken the barcode from the computer table and stuck it on the employee table as the foreign key. This is where, if you knew information or had information on the semantics, this is the rule that you would follow. And here is some sample data. And the next rule is for mapping binary 1 to M or N relationships. I don't know if I mentioned this before, but M and N really mean the same thing. They both mean many. So from binary 1 to M relationships or binary 1 to N relationships, the rule depends on the type of relationship on the N side of the relationship. If the N side is full, include the key from the 1 side in the N side as the foreign key. If the N side is partial, create a new table and include both the keys from both. So basically, again, if the N side is full, it's like you're taking the relationship from the left side and putting it on the more side. So you're taking the key from the 1 side and putting it on the N side as a foreign key. And if the relationship is partial, you create a new table, including both the keys, much like you did in the end-to-end table. So here's an example of a one-to-one relationship with the M side being full. So a supervisor must supervise many employees, but many employees must be supervised by one supervisor. Okay, so here is the example where we took the SSN from the employee table, from the supervisor table, and stuck it in the SSN table. And if we go back to the previous slide, you'll notice that you're taking the key from the 1 side and putting it on the N side. So we're taking the key from the 1 side, which is the supervisor side, and we are putting it on the employee side. Sample data for what we just presented. And now we have the example of the M side being partial and the 1 side being full. And in this case, what we did was we created a separate table called Managed, which has the SSN and the employee ID, the primary key of both tables, much like the end-to-end relationship, and some sample data. So basically what we've done in this chapter is we've talked about cardinality constraints, and we've shown how cardinality constraints are shown with the 1 or the M on the side that we're talking about the cardinality constraints on, and the participation constraints, which may be either full or partial. The participation, once again, is a may or a must. So an employee may have many dependents, and many dependents must being full participation, and dependents must have an employee. So the participation ratio shows the full or the partial participation, the may or the must. With this, I think we end this chapter, and I hope you've got a better understanding of what cardinality ratios are and what participation is and how to do the mappings and the different mapping rules. Obviously, if you need to, you can listen to this recording again, but make sure you read through the book also, and make sure you understand the cardinality, the participation, and the mapping rules. This chapter is extremely important, and it's really the backbone or the basis for understanding ER mappings to relational mappings. Because as I had mentioned way back, probably a few sets of slides back, there's no point in drawing an ER diagram if we cannot correctly map it to a relational database. We have to learn to map it to a relational database correctly, and this is what this chapter is starting to show us. And this chapter, like I said, is an extremely important chapter, so make sure you understand it as well as you can. Listen to the recording if you have to again. Make sure you read the chapter over and over until you understand it completely. Goodbye, and see you later. Bye.